All right, guys, this is page 2 of the absolute value review. Remember that you should be trying these problems on your own and coming back and checking your answers, and only, watching the video if you need help. Please don't just watch the video and do the problems with me, because I promise I know how to do the problems, but that's not going to help you on the test tomorrow, okay? All right, so this is page 2 where we're solving equations. The first thing that we do is we're going to remind ourselves how to simplify absolute value expressions. Remember that absolute value expressions take the numbers inside the absolute value bar and make them positive. But absolute value only affects numbers that are inside the absolute value bars, not anything on the outside. So right here, absolute value of 25, it takes the number inside the absolute value bar and makes it positive. Here it's a 25, it's already positive, but the absolute value of 25 is just 25. Here we have the absolute value, or negative absolute value of -1. Remember that absolute value only affects the thing inside the absolute value bar, so it's only going to have an effect on that piece right there. The negative on the outside is going to stay. And so this is negative of +1, because it turns the -1 positive. And so that's -1. And that's the simplified version of that right there. All right, for number 11, we have 2 absolute value expressions. We have this 15 and this -8. The plus sign is not between absolute value bars, okay? So it's the absolute value of 15 and the absolute value of -8. 15 is already positive, but the absolute value of 15 is 15, and then plus. And then the absolute value of -8 is +8. So 15 plus 8 is 23. Again, what we're looking at here is 2 absolute values. It's the -5 and then the 9 are an absolute value. There's a multiplication sign. I'm going to zoom in so y'all can see. There's a multiplication sign and a negative sign. That's not times minus, it's negative. But neither of those is inside the absolute value, so our absolute values don't have any effect on those. So the absolute value of -5 is +5, and then times negative, and the absolute value of 9 is 9. So times -9. And 5 times -9 is -45. And that's the solution to that one. Okay, let's tackle these equations. Now remember that when you solve absolute value equations, what you are going to do is you're going to write 2 equations. One that looks exactly as you see it, but without the absolute value, and the other one that has a negative on the number that's involved in the equation. So over here, first thing you do is get the absolute value alone. That's not something we have to do for any of these problems. For all of these, the absolute value is already alone. So for this, absolute value of x is equal to 14. We write 2 equations. X is equal to 14 and x is equal to -14. And guys, please notice that neither of my equations have absolute values in them. I can't solve an equation if it has an absolute value on it. So when I write these 2 equations, what I've done is I've taken care of the absolute value. Now, there is not any solving that needs to happen here. These are already solved. The absolute value of x is equal to 14. Well, x could be +14 and x could be -14, and those are just our solutions. It says graph the solutions on a number line if possible, so we'll draw our number line, and here's -14 and +14. Just draw dots. No shading because it's not an inequality, it's just an equation. All right. Here we have absolute value of x is equal to -27. Again, you write one equation exactly as you see it, but without the absolute value. So x is equal to -27. And the second equation you write without the absolute value, and then you change the sign on the number on the right. So instead of a -27, it'll be a +27. There's also no solving to do here, but we do need to check. And so when I plug this -27 into the absolute value negative 27 is equal to negative 27. Well, remember that absolute value takes any number and makes it positive. And so what we come up with is 27 is equal to negative 27. That is not true. Positive 27 and negative 27 are not the same. This doesn't work. Same thing happens if we check the other solution. It's the absolute value of 27 is equal to negative 27. Again, this is positive 27 and negative 27. They are not equal, and this is false. And what that means is that there is no solution. That means you don't have to graph it. If you could tell at the beginning that there was no solution, that's fine, and you can tell me no solution, but you have to explain why. The reason why, guys, is because the absolute value of something will never be negative. So absolute value of x can't equal negative 27 because absolute values have to be positive. That 27 isn't positive, it's negative. All right, let's look at number 15. Here we actually have an equation to solve after we write 2, which is exciting. This is the absolute value of x minus 8 is equal to 12. We do not need to do anything before we write 2 equations, the absolute values alone. So I'm just going to go ahead and write the 2 equations, one exactly as I see it, but without the absolute value. And the second, where the absolute value quantity is the same, x minus 8, but I change the sign of the 12. And so I've got 2 equations. I'm going to come up with 2 solutions. To solve these equations, I'm going to add 8 to both sides, and I get x is equal to 20. If I add 8 over here, I get x is equal to negative 4. You do always want to do a check on your answers, a mental check at the very least. If I put 20 in here to the absolute value, 20 minus 8 is 12. That makes this equation true. And negative 4 minus 8 is negative 12, and the absolute value of negative 12 is 12. Both of those check out. I'm going to graph them on a number line. So here's my negative 4 and here's my 20, and you just draw dots on both of them. Nothing intense. All right, guys, the next 3 equations, we are going to have to get the absolute value alone before we can do any solving. So I want the absolute value of x plus 4 alone before I can do anything like breaking it into 2 equations. Okay, and so I get that absolute value alone by subtracting 12 from both sides. And so I get the absolute value of x plus 4 is equal to it's not 14. It's 16, guys. It's equal to 16. This is what happens when you write in pen. Now, I now have an alone absolute value. There's nothing else over here. And so what I'm going to do is I'm going to write 2 equations without absolute values. One exactly as you see it, x plus 4 is equal to 16, just without the absolute value. And the other with the opposite sign on the 16. So x plus 4 is equal to negative 16, like that. And then we're going to solve both equations. I do that by subtracting 4 from both sides. So x is equal to 12, and x is equal to negative 20. Again, you want to do a mental check on them and make sure. You can do a written check if you want, but you want to make sure that they actually make the equation true. So 12 plus 4 is 16, and that absolute value is definitely positive 16. Negative 20 plus 4 is negative 16, and the absolute value of negative 16 is positive 16. They both check out. I'm going to draw a quick number line. Here's my negative 20, and here's my 12. And I draw dots at both of them. All right. So for number 17, again, we need to get the absolute value alone before we split the equation into 2. And so I'm going to do that by first getting rid of this number. That's always your first step. So I'm going to add 16 to both sides. And I get 5 times the absolute value of 4x minus 10 is equal to 40. And then what you do is you get the absolute value alone. by dividing by this 5. That 5 is being multiplied by the absolute value, so we divide by 5. And that cancels out those 5s, right there, cancels out those 5s, but it doesn't do anything to the absolute value, so we end up with the absolute value of 4x minus 10 is equal to 40 divided by 5 is 8. And so now I have an absolute value equation where the absolute value is alone, and I break it down into 2. One exactly as you see it, but without the absolute value, and one where the number on the right becomes negative. So 4x minus 10 is equal to negative 8. Solve both equations. So 4x is equal to 18, divide by 4, and x is equal to 18 over 4, which is 9 halves. Don't freak out that they're fractions, it's totally fine. And then over here, again, add 10, and you get 4x is equal to 2, divide by 4, and you get x is equal to 1/2. 2/4 is 1/2. Again, don't freak out that they're fractions, it's totally fine. You want to do a mental check on these and make sure that they work for the equation. You can come back to this equation right here if you want to. 9 halves times 4 is 18, minus 10 is 8. And then 1/2. 1/2 times 4 is 2, minus 10 is negative 8. If we take the absolute value, that's 8. And so we're good. How do I graph this on a number line? Well, 1/2 is smaller than 9 halves. So here's my 1/2, and here's my 9 halves. And I just draw a dot at each of them. Fractions are our friends, and often food. We should like them, and we should deal with them more. All right, looking at number 18, again, I've got to get that absolute value alone. So the first thing I do is I move the 8, and so I get 2 times the absolute value of x minus 12 is equal to 0. At this point, I want to get that absolute value alone, so I'm going to divide by 2, and that's going to cancel out those 2's. I don't do anything to the absolute value. I divide this side by 2 as well, and I get the absolute value of x minus 12 is equal to 0. This is a special case. I can't write 2 different equations. There's a 0, and I can't change the sign on 0. 0 is 0 is 0 is 0 is 0. It's always 0. And so instead of writing 2 equations for this, because it's equal to 0, I'm only going to write 1. So x minus 12 is equal to 0. Add 12, and I get x is equal to 12. And there's just one solution. If you think about these absolute values as v's that go through particular points, this one right here is a v that goes through 1/2 and 9 halves. This one is a v that just sits on the x-axis. Now you don't need to draw that on your test tomorrow, but that's what's happening there, and that's why it happens. Just like when we were graphing, the first problem we did on page 1 sat on the x-axis at -5. So the solution was -5. There was only one solution. And that's what's happening here as well. It's a v that sits on the x-axis at 12. And that's what that looks like. Again, you don't need to do that. You need to tell me x equals 12 and draw me a dot on a number line. All right. Oh, one more of these. How exciting. And so the way that we do this, guys, is we subtract 6 from both sides, and you get -2 times the absolute value of 4x plus 7 is equal to 4. And then I need to get rid of that -2, and so I'm going to divide by -2. Gets rid of it over there, and I get the absolute value of 4x plus 7 is equal to -2. And you should be yelling at the screen right now to tell me to stop, because I don't need to go any further. And the reason I don't need to go any further is that I cannot have an absolute value that is equal to -2. The absolute value of 4x plus 7, no matter what x is going to be positive. It will never be -2. And so this is a no solution problem. And those are fun because we get to stop there and be like, no solution. You do need to tell me why. And we would say because absolute value cannot equal a negative number. And that's extreme shorthand, but I'll take it. You could write it in words because the absolute value of something cannot be negative. All right, number 20 looks a little different. Instead of having a number on the right side of the equation, we've got another absolute value. We solve these equations exactly the same way, which is that you write one equation exactly as you see it, but without the absolute values. And then you write a second equation where you change the sign on the right side. So it's 2x plus 6. That stays the same, but it's equal to negative x minus 9, like that. And so I changed the sign for the whole thing. You want to make sure you put parentheses around it. We're going to solve both of these equations. So this one I'm going to subtract x, and I get x plus 6 is equal to negative 9. Subtract the 6. X is equal to negative 15. And then for this one, we distribute the negative. So we get 2x plus 6 is equal to negative x plus 9. Add x. 3x plus 6 is equal to 9. Subtract the 6. 3x is equal to 3. Divide by 3. X is equal to 1. And you want to check and make sure both of those things work out. So when we plug in the negative 15, we get, here we'll check. We get the absolute value of negative 30 plus 6 is equal to the absolute value of negative 15 minus 9. Negative 30 plus 6 is negative 24, and negative 15 minus 9 is negative 24. That checks out. Absolute values on that are 24 is equal to 24. And then for the 1, we get the absolute value of 2 plus 6 is equal to the absolute value of 1 minus 9. This is the absolute value of 8 is equal to the absolute value of negative 8. That also checks out. That works. And so both of these are solutions. All right, guys, that's it for page 2 of the review. Make sure that you are working through the problems and checking your answers. And I will move on to page 3.